Hello students, today we are going to learn about force and pressure. So let us start. Now student, what is force? Force is a push or a pull acting on a body. Alright, and it is the result of interaction between two bodies. Let us understand this with the help of an example. In the first example, you can see that the boy is kicking the ball. In order to kick the ball, the boy need to push it. The boy need to apply a force on the ball, right? The force is in the form of a push, right? And in this case, as you can see, two bodies are involved. So therefore, we can say force is a result of interaction between two bodies, right? Similarly, in the next example, you see that the person is opening and shutting the door. In both the actions, to either open or shut the door, we need to apply a force in the form of push or pull. Okay, so again, force is nothing but a push or a pull acting on a body. And to prove our second point, here also we can see it is the result of interaction between two bodies, the person and the door. Right. Now, let us learn something more about force. Force is a vector quantity. To understand this, that force is a vector quantity, I would like to first explain you that every physical quantity can be categorized under two. Every physical quantity is categorized under two. One is scalar quantity and the other is vector quantity. Now, scalar quantity are those quantities which has only magnitude. Whereas vector quantities are those quantities which has both magnitude as well as direction. And direction. Now, how do I explain you this? Let us take an example of a scalar quantity like mass. Mass is a scalar quantity. Students, you must have gone out to buy groceries with your parent. When you go out to buy grocery, suppose your mom buys onion. So how much she buys onion? The mass of the onion may be 2 kgs, 3 kgs. So how does she mention it to the shopkeeper? She tells the shopkeeper to give her 2 kgs of onion. Suppose 2 kgs of onion. So 2 is the magnitude. Magnitude is the value of a physical quantity. Okay, so 2 is the magnitude. Here you can see there is no direction mentioned. Have you heard anyone saying 2 kgs of potato in the southeast direction? Haha, no one, right? So mass is a scalar quantity. It has only magnitude, right? Similarly, temperature, time, etc. are all scalar quantities and they have only magnitude and no direction. Now let us come to vector quantity. Vector quantity has both magnitude as well as direction. For example, when we talk about force, you see, if I tell you this person A is applying a force of 10 Newton. Here in the figure, you can clearly say that the force is applied in this direction. But suppose the figure is not given to you and I tell you a person A applies a force of 10 Newton. Then you are clueless where the person A is applying the force, right? The force can be in this direction, it can be in this direction, it can be in this direction, it can be any other direction because the direction is not mentioned here. So to specify force, you have to mention both magnitude and direction. To completely define force, we need to know its magnitude as well as its direction. Therefore, we can say that force is a vector quantity. So students, remember, every physical quantity which has both magnitude as well as direction is known as a vector quantity, right? So force is a vector quantity. So a force has both magnitude as well as direction. The measurement of the strength of the force on an object is the magnitude of the force. How much force is being applied? The measurement is the magnitude of the force. Two or more forces can be applied on an object in the same or different direction. As you can see here, in this particular diagram, the force is being applied by person A and person B in the same direction. So in this case, when the force is applied in the same direction, the net force applied on the body, which is also known as the resultant force, the net force or the resultant force on the body will be equal to the sum of the two forces. That means A plus B. Whereas in the second example, you can see person A is applying a force in this direction, whereas person B is applying a force in this direction. Clearly, both the forces are opposite to each other. So in this case, the net force or the resultant force will be equal to the difference between the two forces. Now, how are you going to calculate the difference? It will be the greater force minus the lesser force. So suppose A is more than B. So we are going to write A minus B. I hope that is clear to all of you. Now let us see in details when forces are applied on an object in the same direction. As I told you, forces applied on an object in the same directions add to one another. When two or more forces applied in the same directions, then the net force is the addition of magnitude of both the forces. In this example, you can see person A and person B is applying a force on person C. F1 is applied by A and F2 force is applied by B. So, if we take the net force, if we calculate the net force applied on C, it will be equal to the sum of the two forces applied. That is F1 plus F2. In this case, the values of F1 and F2 are given. So 7 Newton plus 10 Newton. That makes it 17 Newton. Now let us move on to another example. When two forces is applied on an object in the opposite direction. If two forces act in the opposite direction on an object, the net force acting on it is the difference between the two forces, as I already told you. For example, when two persons push the box in the opposite direction of each magnitude 4 Newton, suppose both of them are applying a force of 4 Newton each, then in this case, the net force or the resultant force will be equal to 4 Newton minus 4 Newton. That will give you 0 Newton. Hence, the net force acting on the object is 0. That means the box will not move. Had one force been greater than the other force, for example, had person A applied a force of 10 Newton and person B applied a force of 6 Newton, then in this case, the net force on the object would be 10 Newton minus 6 Newton, that is 4 Newton. And the direction of the net force will be in the direction of the greater force. In the direction of the greater force, right? I hope this is clear to you. Now let us see another example. In this case, suppose it's something similar like a tug of war. The person is standing and two-person is trying to pull this person with the help of a rope. So this person A is applying a force of 450 Newton and another person B is applying a force of 450 Newton. So in this case, the net force applied on the person C will be 450 plus 450. That will be 900 Newton. And the direction of the net force, as we know, force is all about magnitude and direction. We have found the magnitude. What will be the direction of the net force? It will be the same as the two applied forces. Right. Now in this example, which is more similar to tug of war, you can see a force is applied 320 Newton on the left hand side and another force of 300 Newton is applied on the right hand side. So in this case, the net force will be 320 minus 300 Newton. So the net force will come as 20 Newton and the direction of the net force will be towards the left hand side. That means towards the direction of the greater force. Now students, I would like to tell you the concept of balanced and unbalanced force. Balanced force and unbalanced force. What do you mean by a balanced force and what do you mean by an unbalanced force? Wherever the net force is zero, wherever the net force on an object is zero, then we term it as a balanced force. Now, unbalanced force are the forces where the net force comes to a particular value. Then in that case, it will be an unbalanced force. Like in this case 1 and case 2, both the cases, the forces are unbalanced. Is it clear to all of you? If we see in this scenario, the example which is given in the box where 4 Newton is applied by the two objects in the opposite direction, the resultant force is 0. This kind of force is an example of balanced force. In case of a balanced force, if the object is at rest, it will remain at rest because the net force acting on them will be 0. Similarly, if the object is moving with a certain speed in a certain direction, it will continue to move with the same speed in the same direction because the net force acting on it would be 0. I hope the concept of balanced and unbalanced force is clear to you. Now let us see the effects of forces. Force can change the state of rest or motion. If the object is at rest, force can bring it to motion. If the object is in motion, the force can bring it to rest. As you can see, this boy is kicking this box and the box is coming to motion. A similar example can be seen here too. Force can change the speed and direction of moving object. A cricketer, a batsman, when hits a bat, the speed and direction of the ball changes. Force can change the shape of an object. You can see if you poke the balloon with your finger, the shape of the balloon changes. Similarly, you must have seen your mom kneading a dough. So whenever she kneads dough for your chapati, the shape of the dough changes on the application of the force. Force can change size of an object. A rubber band, when stretched, it changes the size. So stretching a rubber band is a way of applying a force on it, and hence the size of the rubber band changes. So these were few effects of force. Now let us see what are the types of force. Force can be categorized in two broad categories. One is a contact force and the other one is a non-contact force. A contact force is a force that is applied by objects when they are in contact with each other, whereas a non-contact force is applied on an object by another object that is not in direct contact with each other. Contact force comes into action with interaction between two objects, whereas a non-contact force comes into play when objects do not have a physical contact between them. That is, when a force is applied without any actual interaction. When we talk about the examples of contact force, we have muscular force and frictional force. Examples of non-contact force are gravitational force, electrostatic force, and magnetic force. Now let us see each of them one by one. First is the muscular force. Muscular force is the type of force wherein we use our physical strength to change the state of motion of an object. We use our muscles, right? For example, man pushing a car. We need a lot of muscular strength in this. So the kind of force applied here is muscular force. Bullocks pulling a cart of load. Cycling, weightlifting, even when your mother needs a dough for the chapati, even when your mom rolls that dough into the form of a chapati, what kind of force is she applying? A muscular force, right? Now let us see what is a frictional force. Frictional force is the type of force which acts when one object slides over the other. It always acts opposite to the direction of motion of the object. Therefore, frictional force is always known as an opposing force. Why is it known as an opposing force? Because it always acts opposite to the direction of motion of the object. Let us see a few examples of frictional force. A ball rolling along the ground gradually slows down and finally comes to rest. You can try this by yourself. If you simply take a ball and roll it down along the ground, you'll see it will slow down and finally it will come to rest. Why is it happening so? It is happening because in the opposite direction continuously a force is acting on it, and that force is known as the frictional force, right? When we stop pedaling a bicycle, exactly, it gradually slows down and finally comes to stop. Again, why? Because of the frictional force between the bicycle wheels and the ground. A car or a scooter comes to rest once its engine is switched off. A boat comes to rest if we stop rowing it. So all these are examples of frictional force. Now let us see what are the types of non-contact force. The first type of non-contact force is a magnetic force. Magnetic force is actually that takes place between a magnet and another magnet, or a magnet and another magnetic substance. So a magnet can exert force on either another magnet or a magnetic substance without being in contact with it. And that is why it is categorized under non-contact forces. Opposite poles of a magnet attracts each other and same poles of a magnet repel each other, as you can see in the figure. Always remember, a magnet always attracts a magnetic substance. Whereas when it is brought close to the another magnet, suppose they are brought close to the opposite pole of another magnet, they will attract the other pole. And if it is brought towards the like poles of another magnet, then there will be a repulsion. Now let us see what is an electrostatic force. An electrostatic force: when a charged body exerts a force on another charged body or uncharged body, is called an electrostatic force. This force comes into play even when the bodies are not in contact. The electrostatic force, therefore, is another example of non-contact forces. Now let us see from the examples that's given to us. If you take a comb and rub it through your dry hair and then bring it to the bits of papers, you will find the bits of papers will get attracted to the comb. Same way, if you bring two like charges, they are going to repel, whereas two opposite charges are going to attract each other. A charged body always exert an attractive force on an uncharged body. Now, the last type of non-contact force is gravitational force. Objects or things fall towards the earth because the earth pulls them. We all know about gravity, right? So this force is called the force of gravity or just gravity. Unlike the other two forces, that is the electrostatic force and the magnetic force, in both the cases, they can attract as well as repel. But gravitational force is an attractive force. It always attracts and it never repels. The force of gravity acts on all objects. The force of gravity acts on all of us all the time without us being aware of it. Since Earth attracts all objects, even without coming in contact, thus gravitational force is a non-contact force. Now let us see few examples of non-contact force. Water begins to flow to the ground as soon as we open the tap. Water in the river flows downwards due to force of gravity. Leaves and fruits falls to the ground on detaching from a tree. So students, gravitational force actually acts between any two objects. Pressure is force acting per unit area of a surface. We can write pressure as force upon area. The SI unit of pressure is Pascal. Actually, we can also say that the SI unit of pressure is Newton per meter square, and 1 Newton per meter square is same as 1 Pascal. The pressure exerted by an object depends upon its surface area. If the surface is small, the amount of pressure applied is large, and vice versa. As you can say, we know that pressure is force upon area. If force is kept constant, force is constant, what we can say about the relationship of pressure and area is pressure is inversely proportional to area. Now, when pressure is inversely proportional to area, that means for greater area, a lesser amount of pressure is needed. Whereas if the area is small, the pressure needs to be great or large. You see here in this example, a potter places a round piece of cloth when they have to carry heavy load. By doing this, they increase the area of contact between the head and the load. With the increase in the area, the pressure exerted by the load on the potter's head decreases, and hence it becomes easier for the potter to carry loads. Now let us see a few more points about pressure. A needle has a pointed end that has a very small surface area. Hence, when a large force is exerted upon the needle with the hammer, the pressure on the needle increases and it easily moves inside the wall. The shoulder bags which we carry to school have broad straps rather than thin straps. Why? It is in order to minimize the pressure that would be exerted on the shoulders of the carrier due to gravitational force acting on the bag. Tools that are used for cutting and piercing always have sharp edges. You must have seen knives in your kitchen. They have really sharp edges, right? Because as a person would apply a force on the tool, its sharp edges would exert more pressure due to less surface area, and the object would cut down easily. A two tire of a tractor are wider because it minimizes the pressure exerted by the tractor on the ground. As a result, it becomes easier to move the tractor on a muddy field. Camels, they can walk easily over the sand. Reason is because it has wide feet which allow them to walk on the sand easily. Human beings, on the other hand, cannot walk as easily on the sand as camel, as their feet have less surface area, and therefore our feet sink in the sand because we apply more pressure on the sand. That was pressure due to solids. Now let us see what is pressure due to liquids and gases. So students, to understand, we should know that fluids also exert pressure. Fluid means liquids and gases. So liquids and gases exerts pressure too. Liquids exert a pressure on the walls of the container in which they are put in. The pressure that a liquid exerts on the bottom of the container is dependent upon the height of the liquid in the container. So, how much pressure is exerted by the liquid on the container will be dependent upon the height of the liquid in the container. The liquid exerts equal pressure on different points of the walls of the container having the same depth. For example, if you have a container like this and there is a liquid in this container, consider this depth. Suppose at this particular depth, each point of the liquid will exert equal amount of pressure. Okay. Similarly, gases also exert pressure on the walls of the container. The molecules of a gas of higher kinetic energy collide with walls applying large force, and as a result, these molecules apply pressure on the walls of a container. Now, to explain my second point, we can come to this figure. If you see in this diagram, three holes are made for the water to go out. So these are the outlets of water in the cylinder. This is a tall cylinder with a lot of water in it. You can see water is coming down from all the holes, but pressure is highest at the bottom hole. Let us name these holes as A, B, C. So students, you can see that water is going farthest from when it is coming out from the outlet C, proving that pressure is highest at the bottom. Whereas if you see the outlet A, the pressure is falling closest to the container, proving that water comes out of the holes, and again it is least at this when it is coming out from the outlet A. Therefore, the pressure that a liquid exerts on the bottom of a container is dependent upon the height of the liquid column. You can also say depth of the liquid column, because we are going to measure the height from the top. So this is H1, the B is H2, this is H1, this is H2, and from top till C is H3. So pressure is maximum at H3, that is at level C. Now, in this figure, you can see pressure acts in all directions. Here, you can see this is a plastic bag and holes are made in it, and water is coming out from all the points, showing that pressure acts in all directions. Now, let us come to atmospheric pressure. What is atmospheric pressure? To understand atmospheric pressure, we first need to understand what is atmosphere. Atmosphere is the layer of gases present around the Earth's surface. Layer of gases. Okay, it is present around the Earth's surface. The air present in the atmosphere, they exerts a pressure on the Earth, and this pressure is known as atmospheric pressure. The atmospheric pressure keeps on increasing as we move towards the Earth's surface. That means as we move away from the Earth's surface, the atmospheric pressure decreases. Right. As we move away from the Earth's surface, the atmospheric pressure decreases. The amount of atmospheric pressure upon us is quite large due to the large surface area of the atmosphere around the Earth. But we do not experience any of its effects. Why? This is so because the pressure of the air inside our body is equal to the atmospheric pressure. Therefore, they balances each other and we don't feel any atmospheric pressure on us, right? So what can we say? We can say that there are so many fluids inside our body that exert pressure inside our body. Hence, our body easily obtain a balance with the atmospheric pressure, thereby not experiencing the effects of atmospheric pressure. However, sometimes at higher altitudes where atmospheric pressure is low as compared to the Earth's surface, nose bleeding occurs. You must have heard about mountaineers. When they climb the mountain, they have a risk of nose bleeding. The reason is that when they go up at higher altitude, the atmospheric pressure decreases. So what happens? There is a disbalance. The blood pressure was actually balancing the atmospheric pressure, but at higher altitudes the blood pressure in our body becomes higher than the atmospheric pressure outside us, thereby leading to nose bleeding. So students, that's all for today. I hope you all understood and I have covered almost the entire topic of force and pressure. If I have left out something, or if you need a better understanding in any particular topic, please mention it in the comment section. Thank you and keep learning.